Right, so in this module, we're going to work to tie together the previous two major topics that we've covered, functions and arrays. And really, there's not a whole lot to it. We can pass arrays into functions, and actually it's a little less complex than passing normal variables because by default it's going to be passed by reference. So we'll discuss a little bit about why that is. And then take a look at another example of using our top-down design to solve a problem a little bit more complicated using arrays. So arrays with functions is largely covered in section 7.5 and 7.6. And in terms of syntax, the one thing that does require a little bit of memorization here is when we write a function that can accept an array, after the variable name comes an empty with no size in it bracket, right, the square brackets. Now, it's important to realize why that is empty. We do not write functions that accept arrays of size 5, 6, 7. That would mean that we'd have to write separate functions that accept arrays of every conceivable size that an array could be, which is certainly not what we want to do. We want to write functions that are general. They should be able to accept arrays that are of any size, theoretically. So the syntax of C++ has that baked in already. It has that idea. So when we write a function that accepts as a first parameter an array, by default it is allowed to be an array of any size, and it's just that these brackets are saying that this happens to be an array parameter. If it's a double array, that's fine, double x, open and close brackets. So we never put the size of the array in the function definition. And in fact, there's actually nothing being passed into this function likely to say what the actual capacity of the array was. What we do normally put into this array, to this function, is the current count, how many numbers are currently in the array. And if you think about that, that's really crucial. For if you hand in a function an array of values, it really won't be able to work with that array unless it knows exactly how many things are in it. So whenever we write a function that passes an array to a function or accepts an array, there are virtually no circumstances where we would not also pass the count, whatever the count of variables are in that array. Now, if we, for some reason inside this function, we're going to alter the number of values in there, or to add to the array, we'd have to make some special considerations. Possibly we'd have to send in as a parameter to the function what is the overall capacity in addition to what's currently in there. Now, one of the big things that is different between regular variables and arrays is the fact that an array is, by definition, multiple variables. Right? So the name of an array, when we say int x, an array, that could be 5 variables attached to x. That could be 1,000,000 integers. We don't know. And because we don't know, we assume that it could be very large, and we make it by default in C++, because arrays can be so large, we make them pass by reference without any special syntax. So we don't put an ampersand here, ever. There's never an ampersand between the int and the x. However, it is always inferred or always interpreted as pass by reference. So that's important, and it's a little bit of an unfortunate side effect, because for regular variables we need to remember that there's a special syntax, there's a special ampersand, the and sign, to make it pass by reference. For arrays, it happens to be always pass by reference, and there is no special syntax. There are technical reasons why that makes some sense, that actually does make sense in the way this works, but from our perspective, just learning C++, getting our feet wet with programming, that's one of those things that you're really going to have to just remember, and you're going to take as a memorization. Now, I mentioned changing the arrays. If you edit the elements in a function, those changes are reflected outside the function. So inside of a function, if I take all 5 values inside the array and I subtract 1 from them, that's fine. And because the array is passed by reference, those changed values will be propagated to the rest of the program, just as any other pass by reference thing works. If I add or remove elements, that is essentially telling me that I'm changing the count. So if I'm changing the count, if I go back up to this slide here, notice that count is just a regular variable being passed into this function. If count changes, that's a local variable. That's a pass by value strategy. So if I'm going to do that, I need to make sure that count gets passed in by reference as well. And I need to explicitly say pass by reference for that. That's a normal variable. So if I'm going to change the count, we remember that we're going to make that pass by reference. It also, as I alluded to ahead of time, you might also need to pass the capacity in, the overall size. So if the maximum size of this array is size 15, and the job of the function is to potentially maybe ask the user for values and add it in, we need to make sure that we tell that function, well, don't add in anything beyond 15 numbers. So there's a lot of different strategies at play. What if we want to make sure that, we think about pass by reference, and pass by reference allows us to change the parameters. If for some reason we really did not want the function to ever change the contents of the array, but since we have pass by reference by default, we really can't, it is always able to change it. One thing that we could do is we could write const in front of the name of the array. So if you knew for sure that this function had absolutely no intention of ever changing the values in X, think that through before you write the function. Should this function actually change values in X? It can change count, but it can't change values in the array, so I don't know why it would change count. If that's the case, then you can mark it as constant and the compiler can verify it for you. Anytime we can let the compiler sort of verify our intent, that's a good thing. So we'll try to use this as much as we can. Functions can accept arrays, they cannot return them. And to be honest, this probably makes a lot of sense, practical sense, because we're passing functions by reference anyway. So since the arrays are passed by reference by default, there really is not much of a need to ever return arrays. You just send the array in into the function, maybe potentially uninitialized, and let the function change the values. From a technical perspective, it would be difficult to return arrays because we don't know how big they are. And we can't really assign arrays. We know we can copy arrays, and we'll look at that a little bit today as well. But we know we can copy arrays, but we can't necessarily just assign them all in one shot. So there'll be no returning. There's no return type of an array, and just remember that if you ever feel that you're trying to write a function that's going to return an array, you're going to have to pass the array in as a parameter instead. Okay, so with everything that we've learned about arrays, and now we can use functions with them, I'd like to tackle probably the biggest programming example we've done so far. And I'm going to write a program that reads two distinct arrays from the user. So it's going to proceed through two steps. It's first going to read one list. It's going to wait till the user types -1, and then it's going to read a second list and wait till the user types -1. And at that point, it's going to determine whether or not the two lists are exactly the same, meaning, and my definition of exactly the same is that they have the same exact numbers in the same exact order, so they have the same number of numbers as well. I'm also going to print out whether they're equivalent, and for the purposes of this example, equivalent is going to be same numbers in any order. So if the user types in 1, 2, and 3 in one list, and then 3, 1, and 2 in another list, I will consider that list equivalent, but not exactly the same. So I'm going to do two tests. And the way I'll do this is that for the test for equivalency, I'm going to go through and find each number in the first list and make sure it appears the same number of times in the second list, and that'll guarantee that they're equivalent. In both cases, for it to be exactly the same or equivalent, they'll have to be the same exact size, so same number of numbers. Now this is big. This has got several different portions to it, and I'm going to start by breaking this down into sort of a top-down design. I'm going to start writing my outline in main, And I'm going to, all major tasks, I'm going to break down into functions until each individual function is fairly small. So, to start out, I got my int main, and the one thing I do know is that I'm going to have two different arrays. So I'll say a1, and let's make the default size here const int size equals 10. Let's make that 10 size. I'll have a2 of size. Now these are going to be partially filled arrays. There's no guarantee that the user is going to type in the same number of values for each one. So what we will have to do in main is have two counts. We have two count variables representing the count in the first array and the count in the second array. So if you've started to sort of commit to memory that you always need a variable called count, remember that that's really just an arbitrary name. So I'll call it count1, and that equals 0, and int count2 equals 0. So that's my initialization. I've got my two arrays and I've got the two counts. And now let's just start thinking about an outline. So first step is to read the first array. So I could sort of write that as the name. But if I think about it, what's the job of read first array? Read first array is going to prompt the user to enter a number until they type in -1. And each time they enter a number, it's going to place that value into a given array. The difference between read first array and read second array, if I was to write a function like that, would really just be only which array to add it into, which actually isn't really that big of a deal because that array, which array, could just be a parameter. So instead of read first array, I'm just going to say read array from the user. And I'm going to pass an array in, first a1. And if we think about what the job of read array, if read array's job is to read numbers from the user, it has to know a couple things. Primarily, it really needs to know how big is this array, because I can't let the user type in more than 10 values. So I'll throw in size as a parameter. I'm not throwing in count here because count, of course, is assumed to be 0. Count would be 0 if I'm reading an array in, or if I'm asking read array to populate this array. It's starting out with nothing in it. So read array can assume that the first value goes into 0. However, it's going to return some important information to us because it's going to return the number of numbers the user's typed in, the count. So in fact, I can say count1 equals read array, pass in a1 and size. So the end result of this is send in, or so the output or the result will be a1 has values from user, count1 represents number of items entered. And I'm going to create a read array 2, or call read array with a2 as well for count1 and count2. Now I don't have that function yet, and I'll write the stubs to compile in a second. But that's my first step, read the array. And that's going to consist of a do-while loop to read this array in and return back to main count. And in fact, I could just declare them right here as well. Next, I'm going to say is, or if, equal. And I'm going to pass in a1, a2. And that equal function is going to evaluate whether or not a1 and a2 are exactly the same. However, to be able to do that, we're passing in two arrays. We also are going to need to tell the equal function when I write it how big these arrays are, because I don't know whether the user's typed in 1 value or 3 values. So I'm going to have to pass in the counts as well. Count1 count 2. So I'm passing to this new equal function array 1 and how many numbers are in array, array 2 and how many numbers are in that array, and this equal function is going to return true or false. All right? True if they're equal, false if they're not. So I'm just going to put it right in there. If it's equal, I'll say arrays are equal, and otherwise I'll check to see whether they're equivalent. Of course, if they're equal, they're also equivalent, so I'm not going to really bother with that. So I'm going to write a function called equivalent. It accepts the same exact stuff. And if neither one of those are true, I'll just print out that they're completely different. Okay, so looking at this outline, it's certainly taking this top down. We have to kind of think a little bit creatively on how these functions are going to work. But I've created two functions, or I've called one function twice to read my arrays in. I've told read array to read data into the first list and return the first count. I've called this hypothetical function to also read from the user into array 2 and provide a count 2. And now I'm checking to see whether they're equal. And in true top-down fashion as well, I'm just sort of pretending that equal and equivalent already exist. But I've already thought through sort of what they would look like, right? So to be able to determine whether two arrays are equal, I need to pass the two arrays in, and I need to pass the counts of those two arrays in, and I should be able to say yes or no. So I'm having it return a Boolean type, and I'm just using it directly in the if statement. And equivalent is doing much of the same. So now I can write some function prototypes. Read array returns the count that is read, so it returns int. Read array, first parameter is a array. I'll just call it a. Okay. Open and close bracket. And the second parameter is an overall capacity. So that's what read array is going to look like. Equal is going to return Boolean. It returns true or false, a yes or no question. And it's going to take an array, and I'll call it, I'll call it A1 for here for now. It kind of makes sense. And count 1, and an array 2, and a count 2. And equivalent's going to be essentially the same thing. Now we're probably going to need some more functions as we build this out, but for now, actually, before I even continue much further, what I'd like to do is actually print the arrays out after I print this. I want to print the values of the arrays, and I'm going to write another function for that. I'm going to say print array A1, and I'll need to tell it how many things are in it, and call print array A2 count 2. Maybe print out a little dash between them. And that I'm kind of thinking ahead, and I probably want to see those values come out just for debugging purposes. So I'm also going to put in a print array. Now, the print array doesn't return anything void. It accepts an array and a count to print it out. So I'm putting that there so I can continue to print the lists out just to make sure that for debugging purposes. Now let's copy these prototypes and move them down here and start implementing some of them. I'm really not going to implement equal and equivalent just yet. I'm just going to return false. Keep that simple. Those are the bulk of the work that we have to do eventually, but we'll build the rest of the program first. For read array, I'm just going to return 0. just to get this thing compiling. Print array I might as well write. That's so simple. We've done this a few times already. So for int I equals 0, I less than count, I plus plus, cout, ai. So, we write it as a function just so we don't have the separate for loop everywhere in our main function. But that's such a simple and easy function, might as well just write it right away. So when we run this, of course, now since read array is not doing anything, we're not going to get much of an exciting output. So it comes out and it says these arrays are completely different, which of course makes sense because a read array didn't do anything, just returned 0, just returned 0. We called equal, it returned false. We called equivalent, it returned false. And then we called print array, and that of course didn't do anything because count 1 and count 2 are both 0, but we did see the dash. All right, so next stop. Let's do read array. We can't really go much further without read array. So the job of read array is to ask the user to continue to ask for numbers to read into this array up to capacity or until they type in -1. And this is actually right from programming example 30. We could almost just take the code that we wrote in programming example 30 and copy it right into this function because it's exactly the same other than the name of the array and the name of the capacity instead of size. So I'm going to create a count variable and initialize it to 0. I'm going to do a do while loop while my input, and of course I'm going to remember we never read directly into the array, so we're going to have an input variable. While input is not equal to -1 and count is less than capacity. If you look back on programming example 30, this is the exact same loop with the only difference that capacity was called size. And that was that just happens to be by chance the way I coded it. So I'll read it into input. If input is not -1, I'll put it into the array. Which array? Well, this one right up here. Count gets incremented, and I'm done. Now the only difference here is that because read array actually has to communicate back, it has to. The array, of course, is passed by reference automatically, so changes that it's making here will be reflected. So when I call read array with A1, anything that the user types into this A will actually be going right into A1. When I call it with A2, anything that actually is read into A will be going into A2. I also need to return the count though. And there we go. If I run this, now I've filled in a little bit of the details of that function. Now I've got my familiar loop. Type in -1. I right away kind of see that it's I probably need to say, enter list 1 and then have these prompts and enter list 2, because right now it's a little confusing whether I'm reading into list 1 or 2. It was working. It says these arrays are completely different, of course, because equal and equivalent still return false. But I've printed out these values now, and I can see that I did read the values in correctly. And I returned the count, and I used the count later on in my program. So when I return these counts, I also use them to print it. So let's add a little bit better prompt here. First list. Just so the next time we run it, it's a little more clear what's happening. And now we've got to move on to our equal and equivalent, because there's going to be obviously quite a bit more work to this. The first one we can go through is equal. Equal is a little bit easier actually than equivalent. for something, and let's plan this out a little bit. For two arrays to be equal, let's write some lists here. If we have a list like this and we have a list that's actually identical, how do we tell whether those are the same? What makes them the same? Well, criteria one is they are the same length, right? So that's important, right? If they weren't the same length, if I didn't have this 10 here, we could immediately say, okay, well this list is not the same. It's not exactly equal to list. If I had one less number in it, there's no way all these numbers could match up. But if I had the same length, each pair is the same. And when I talk about pairing, I'm sort of talking about this. So I'd actually go through the array, or the two arrays, and check to see whether element number 1 is the same as element number 1 in this list. So if I know that they're the same length, I can just walk through this array one element at a time and look at the corresponding other element in the other array to see whether they're the same. Now so I'd make it all the way through and I'd see that, and kind of conceptually that's clearly how we would evaluate a long list to see whether it was equal. What I'd like to do though is consider the situation where they're not equal. Let's say that they're the same length, 8, 2, and 10, but now we've got slightly different. How do we figure out whether they're equal or not? Well, we're going to still visit each pair, right? So we can imagine sort of like a for loop going and visiting each element. Right? We're going to walk through and check to see whether A1, 0 is the same as A2, 0, and if it is, we're going to continue. We're going to continue that for loop, which we would normally naturally do. If we get to a situation where these values are not the same, notice that we don't even have to continue further. We immediately know that they are not equal. So if we find a pair that is not equal, we can stop our search. We can stop our evaluation. And if we think back and we look at what is equal or equal returns, it returns Boolean. So as soon as we find an element that's mismatched with its corresponding element, we can return false. If we do that, what we'll call this is return early, or early exit. We will return from our function right away, right outside of this for loop. We won't let the for loop continue. If we go through all the way through and we never find a mismatch, when the for loop naturally completes, then we'll return true because we've walked through the entire array and ultimately return true. What we want to avoid is just checking these two numbers and saying, well, these match, so return true. That won't work. We have to visit everything and not find a match for us to be able to return true. So first step, check to see whether they're equal. That's easy. We don't have to look at the contents at all. If count 1 equals count 2, I'll return, or let's say if it's not equal to, return false. We're done. Equal and equivalent will be much the same. They're really looking for conditions to rule out whether this list is equal. And as soon as they find a condition where these lists are not equal, to return false. And sort of as a last resort, it'll return true. Once it's exhaustively looked through its conditions for failure, they're not the same length, one of the pairs is mismatched. Once it's looked through all of that and it's decided, you know what, none of these conditions have been broken, then it will return true. So I want a for loop to visit each element. Now remember, count 1, if we reach this line of code, that means count 1 and count 2 are identical. If they weren't, I would have returned false and I would never get to this line of code. So I don't really care what count I'm using. because I know that they're the same. I'll use count 1. And I want to check to see whether A1I is equal to A2I. So this if statement is essentially looking at, actually I want to check to see if they're not equal. If they're equal, I'm not going to do any action. I'm just going to let the for loop continue. That if statement is just doing this. If that's not true, if they are not equal, I'm going to return false. I found the mismatch. What's really important that you recognize is that we do not have an else clause here to return true. If I put a return true there, what I would be saying is if the first element in A1 doesn't match the first element in A2, return false, otherwise return true. This for loop would never go around more than once because either this is true or it's false. What we want, and as I said before, is to walk through the array, and if we find a reason for rejecting equality, return false. If we never find any situation where that's broken, then we'll return true. So let's test that. We know our main function's already using equal. I'll print out, type in 2 identical lists. And we see the arrays are equal. Let's make sure that if we type in 2 non-equal numbers, or non-equal arrays, those are not equal. They're the same numbers. That's actually an equivalent, but they're not actually equal. And we see they're completely different. And of course, they said it's completely different because, well, yes, they're not equal, so this failed. But equivalent also automatically returns false because we haven't dealt with that yet. So we expect to see arrays completely different. I highlighted this in previous modules, but I think it's worth, especially in this circumstance, just repeating, pointing out that, you know, I still have a program that prints out the wrong stuff. I'm making great progress. I'm not going backwards. I'm not worrying about the fact that these arrays are completely different, even though they're not. I'm really just testing each individual component that I'm writing. So in true top-down fashion, as I complete a function, I test that function. I test whether my program can see if they're equal, but I don't worry about the fact that still I haven't dealt with equivalent. And that is a skill that you really must develop and develop well. The ability to only worry about the parts of the program that you can solve right now, the small part of the program that you're focusing on, and not get distracted by the rest. Okay, so let's see if it's equivalent. How do we figure out whether something's equivalent? Well, if we go back here, I kind of alluded to it. They're equivalent, first off, if they have the same number of numbers, right? So if there's a mismatch, if there's one list has 5 numbers and the other list has 3 numbers, they are not equivalent. There's no way they can be equivalent. So in fact, let's go back to the drawing board here. And you know, so what I'm considering here is if I've got a list like this, and then I got another list like that, those are not equivalent. So for equivalence, they still have to be same length. The second situation, or the second requirement, is that the numbers that appear in the first list must appear the same number of times in the second list. So if we go back here, in this case, if I had something like 4, the number 3 appears once in this list. The number 3 appears once in this list. The number 4 appears once in this list and this list. The number 5 appears once in this list and this list. If I have 3 here, these lists are not equivalent until there's a third or a second 3. 3 appears twice in this list. 3 appears twice in this list. So in terms of coming up with an algorithm to perform this comparison, what I'd like to do is I'd like to visit each number in array 1 and count how many times that number appears in A1. So 3 in A1 appears twice. And then go through and count how many times I find 3 in A2, and I'll see it twice. And I'm going to proceed while these are equal. If they're equal, then I go to the next number, and I count how many times 4 appears. Once, they're equal. Count how many times 5 appears. Once, they're equal. Count how many times 3 appears. And even though I already know this, to simplify my code, I'm not going to worry about the fact that this is the second time I looked for the number 3. If I wanted to get real clever, I could remember the numbers that I already counted. But frankly, unless your lists are very large, that's really not going to save you much time. So if I see the number 3 that second time, I'm just going to blindly say, well, how many times does the number 3 exist in A1? And how many times does number 3 exist in A2? Twice, and they're equal. If I go all the way through this and I never find a situation where that number is not equal, then they're equivalent. If I have, and let's say, let's make this a 4, and let's go back through the same idea. I check through it, so this is 4, 3, 4, 3. I look at this 3. Okay, so 3 appears in A1 twice. It appears in A1 twice. 4 appears in A1 once. I count how many times 4 appears in A2. It's twice. These are not equal. I stop. The list is not equivalent. And then I would just stop. This is an exit early scenario as well, where I would just return false as soon as I saw that. So that's going to be my algorithm. It's sort of a brute force algorithm. I just walk through array 1 and count how many times I find the value. And I do that for every single value in A1. Now notice I don't have to go back and repeat the process and go start from A2 and count how many times I see 4 here and here, because I've already guaranteed that they're the same length. So if the numbers that appear in A1 exist in the same number in A2, then since they're the same length, there can't be any values in A2 that weren't in A1. So take some time to convince yourself if that's a little too fast, but suffice to say, as long as we know that they're the same length, this algorithm here is suitable for testing equivalency. Now, I can go right through and I can implement that, but clearly, this is another opportunity, or should be clear, this is another opportunity for a little top-down design, because all of these numbers, these are counts of how many times I've found a particular number in a particular array. So it's a general problem. Go through a particular array and count to see how many times you find a particular number and return that count. And if I have a function that does that, then this process, this algorithm going through will be a lot easier. And in fact, I'll do a top-down design here. I'll pretend I've got a function that can give me the count of a particular number in a particular array. So I'm going to start off with the same comparison. If they're not the same length, return false. At the end of this, I'll return true if I never find a reason to say they're not equivalent. And now I'm going to walk through, again, they're the same length, so it doesn't matter which count I use. I'm going to walk through array 1. And I'm going to count. So let's say times A1. And I'll call it search. Search A1. And if I'm going to search A1, I need to know how big A1 is. Count 1. And I need to know what I'm searching for. And I'm searching for A1I. I'm visiting every element in A1. And I want to pass in that number. I'll say int times A2. Search A2. Count 1 and count 2 are the same, but for consistency, I'll do that. Now, importantly, I'm searching though for A1. I'm searching for the same number in A1 as A2. Right? So when I looked at the 3 here, I searched for how many times 3 appears in this list and how many times 3 appears in this list, not 4. I didn't care how many times 4 existed in this list. So this was the number that I was searching for, and I searched it in both of them. If times A1 is not equal to times A2, then I've found a mismatch, and I can return false. Otherwise, I just keep going. I just let the for loop complete. And again, if we go through the entire for loop and we never find an inconsistency, we return true. All right, so now we've got the search function. The search function is supposed to return how many times something exists. It accepts an array, it accepts the size of an array, and a number to search for. I'm just going to write that right up here. Int search, int array to search, int count. And often when we're searching, we call it the key. We're searching for a particular key value. So we'll just call it key. Now a search, in fact, now we can go back again, go back to programming example 30, and we already searched through an array and tried to count how many times we found a particular value. And we did that by coming up with an initial count, so num found. We set that to 0. We wrote a for loop that went through the array. And by now, hopefully, these for loop to walk through an array, you've seen it probably 20 or so times in the last few examples. This should become absolute trivial muscle memory for you to write. To write a for loop that visits every element inside of an array. Remember to use that count instead of capacity. And we can check. Does AI equal what we're looking for, the key? If it does, we'll do num found plus plus. If it doesn't, there's really nothing to do. We just keep going. And at the end, maybe num found is still 0, but it's probably, or it could be something more. We'll just return it. So now my equivalent function should be able to use search. So let's type in 4, 3, 2, 1, 1, 1, 2, 3, 4, and we see the arrays are equivalent. Check some more cases. It's kind of a silly case, but I like to test things that seem a little strange, a little out of the ordinary. If I type in 1, 2, 3, and I type in 3, 2, 1, 1, whoops. That's completely different because they're different lengths. It looks like we've got this. The only thing that I would add to it is, we learned about the const keyword, and it might be useful to use that. If we look back up all the way up to our outline, read array is certainly not const. Right? Read array is absolutely changing the array. It's reading in things into the array. But equal, equivalent, and in fact print, all technically are not changing the array in any way. So it might be a good idea to add const in front of this. We need to remember to add const in front of the variables in the prototype as well as the definition. And in fact, and we'll talk about this maybe in a future module a little bit more, the regular variables can be marked const as well. And what we're saying is that count 1 and count 2 would not change. You typically don't see people doing this because count 1 and count 2 are actually passed by value. So whether or not they change or not is really not as big of a concern. We use the const keyword not because it's special for arrays, but it makes sense in the contents of an array because this is passed by reference. So let me go down here and I'll change this to const. I'm just changing all my functions. Actually, I don't want to do that right just yet, but I'll show you that we do need it eventually. And when I compile, I'm going to get these compiler errors. I went and changed all the ones that I had set as prototypes to const, and now I get some errors, and it's right here. Right? So the reason I'm getting compiler errors here is because equivalent is essentially promised that it will not change A1. It will not change A2. But it then calls search, which does not make such promises. Right? And the compiler error immediately says, well, wait a second, you can't do that because you've told me that you're not going to change A1, and you're calling search, which may very well change A1. The compiler's not smart enough to look at this and decide whether or not you're changing A1 or not. So this needs to be marked const as well. So it looks like by the way, remember when we talked about function prototypes, I mentioned that if you change the function prototype and you change a definition or you forget to change one of them, you'll get these unresolved linked errors. That's what we're seeing, unresolved externals. The issue here is that, and I know this is a little bit obscure, but this equal function, it's saying there's a problem with it, and I'm looking at this and I put the const here but not over here. On the equal, I put the const on both, which I should have. And that's what I'm getting with that. So it compiles and it runs exactly the same, but this time it's a little bit more technically clean and accurate by putting these consts here. And again, of course, remember that if you put consts where it doesn't belong or where that doesn't make sense, the compiler is going to kind of yell at you. Read array, if it says that it's not going to change A, it certainly can't. The answer to this is not to stop changing A, of course. It's that the purpose of read array is to change the array. So it shouldn't be const.